Welcome back. Today we're going to be talking about simplifying radicals with cube roots. So let's go ahead and take a look at the difference between square and cube roots. So remember, whenever we have a square root, that's going to be two numbers times themselves. So 7 times 7, for example, is going to be equal to 49. So the square root of 49 is 7. In a cube root, we're going to have three numbers times themselves. So in this case, we would have 2 times 2 times 2 is going to give us 8. So the difference there, for a square root, we have this number multiplied by itself. For a cube root, we have the number multiplied by itself 3 times. Now let's take a look at what to do when we have a non-perfect cube root. So when simplifying a non-perfect cube root, we're going to simplify the non-perfect cube roots the same way we simplify non-perfect square roots, but instead of looking for groups of 2, we're going to be looking for groups of 3. So now let's try that in example A. So here we are in example A, and we're going to simplify the cube root of 24. Now 24 is not a perfect cube root, so we're going to look for prime numbers, try and break it down as far as we can, and then pull out groups of 3. So 24, I'm going to say, is an even number, so I know I can break that down to 2 and 12. And then 12 is not a perfect square, but it can be multiplied by 2 and 6. And then 6 can be broken down to 2 times 3. So just like with square roots, we're looking for groups, but this time we've got cube roots, so we're looking for groups of 3. So I can see here that we have one group of 3, which is 2. So that's going to go on the outside of my radical, and then the only number left on the inside is the 3. So the 3 is going to stay inside my radical, and therefore I have it simplified. However, there's one more thing I need to do. This is a cube root, not a square root, so I need to make sure that when I'm writing my answer, I have a cube root drawn in, not a square root drawn in. Now let's take a look at example B. All right, here in example B, I've got the cube root of 128. So again, I'm going to break that down. I'm going to see that it's an even number, so I can take it to 2 and 64. Then I can see that I know 64 is a perfect square. I know that's going to break down to 8 and 8. Then I can break down 8 and 8 even further to 2 times 4 and 2 times 4. And then my 4s are going to be broken down even more to 2 and 2 each. All right, so now again, it's a cube root, so I'm looking for groups of 3. So I've got one group of 2's here that are 3, and I've got one group of 2's here that is going to make a group of 3. So that's going to be 2 times 2 on the outside, and then I'm going to have just one 2 left on the inside. So again, I need to make sure that I'm writing this as a cube root. So I've got my little 3 cube root. That 2 is going to stay on the inside. 2 times 2 is going to give me 4. So 2 times 2 is 4. Bring down my cube root with the 2 on the inside, and that is my simplified answer. Now let's take a look at example C. All right, here we are at example C, and it's got a little bit of a trick to it because it's got a number in front of the cube root, but as we learned with square roots, we're going to take whatever we get and just multiply it by that number, the thing that we pull out. So we're going to focus on finding the cube root of 40. So we're going to go ahead and break that down. I know that could be 5 times 8, and then 8 can be broken down to 2 times 4, and I know 4 can be broken down to 2 times 2. All right, so now I'm going to look for groups of 2. So I've got 3 groups of 2 right here. So I know that's going to be on the outside. I already had the 8 on the outside, so I've got 8 times 2 on the outside of my little cube root here. The only number that's left inside is this 5, so I need to make sure that stays inside my radical. 8 times 2 is going to give me 16. Then I'm going to have my cube root, 16, cube root 5. Now let's take a look at example D. Now here we've got cube root of 250, and 250 seems like a big number, but this time I'm going to use a little bit of a trick. So I know that I can break down 250 to 125 and 2, because 125 times 2 is 250. Now here's where the trick comes in. I know 125, I know the cube root of 125. 125 is a perfect cube root of 5, because if I do 5 times 5 times 5, I'm going to end up getting 125. So if I know that that's a perfect cube root right there, I know that that's a group of 5 that I can pull out. The 2 is the only other thing that's left inside, and I have my cube root of 2. And I am done. So if you're able to memorize some of the cube roots or identify a perfect cube root as you're breaking things down, you can make your job a lot easier. That brings us to the end of this problem. It also brings us to the end of this set of notes. If you like this video, you're going to say thumbs up. If you love this video, you're going to say sub. And we will catch you in the next one.